Hello and welcome. This video is on the Prepare menu. Many people use a spreadsheet to organize their data. Here, we use an example of climatic data to consider how this might be done. We then illustrate how a statistics package could be used for this tidying process instead. We had a student with climatic data explain his task as follows. I have daily rainfall data in Excel. Each year is in a separate sheet. I first need to analyze the annual rainfall totals and the number of rain days. They are on row 36. Then, I have to analyze the monthly data. They are also shown. Later, I will need to add data from more stations and where more elements were measured, including temperatures. How do you plan to do this? I'll copy row 36 and paste to a new sheet. Then repeat this for the other years. Later, I'll do more copy pasting for the monthly data. Do you anticipate any problems? The number of rain days are all the days with more than 0 rainfall. I would like to just consider those with 1 millimeter or more as rain days instead. And what is the plan when you have more stations and more elements and also perhaps more years of data too? That's for later. I'm a pretty neat copy paster of data, but maybe you have a different plan? I do. I'd like to use R to first get a tidy version of the daily data, then calculate the annual and monthly summaries from the tidy data. Your data are daily, so we will produce a rectangle with days going down and your measurements going across. Look at this dataset to see the sort of thing that we are aiming for. And when you have more stations and measure more elements, it will remain the same shape. Here is an example of 40 stations in Zambia, where 3 elements were measured. Here is your rainfall data going down, together with the maximum temperature and minimum temperature. And here is the main date information. Wow, that's nothing like my shape above. This tidying or preparing sounds difficult. Why didn't I learn anything about it in my statistics course? It can feel annoying that the preparation stage can be at least as time-consuming as the subsequent analysis. But a good analysis cannot be done on a messy data. R is excellent at this data tidying process, and hopefully you will see that the R-Instat Prepare menu makes it all pretty easy to do. Bear in mind that your data are more challenging than most. If you can tidy this data, you can tidy almost anything. Why this isn't taught more is a mystery to me. It is now well covered in data science teaching, where it is called data wrangling. Oh, and as you tidy, try to become a data detective, working mindfully, looking out for oddities in your data and clues about why they are there. For example, here we will discover 1 year with 13.7 millimeters of rainfall on 31st September. The data are in the R-Instat library. From the R-Instat opening page, use the Import from Library icon or shortcut. Choose Load from Instat Collection tab and navigate to the Climatic folder, then the Cameroon folder, and finally select Garua 1999. First, check that a single year loads easily into R-Instat. Select 2013 Stats by clicking the checkbox. From the preview, it looks okay. Click OK to see it in full. In R-Instat, it has loaded all 36 rows of data, so the summaries at the bottom are included. These rows are now messy, and those bottom rows have resulted in January and April being character type columns. Discovering all this is the start of your detecting process. We could delete these summary rows, but we want to import the other years, so it is easier to start again. Delete the 2013 stats data frame by right-clicking on the bottom tab. Select Delete to open the Delete Data Frames dialog and click OK. Return to the Import from Library dialog and again choose Garua 1999. This time, use the maximum rows to import options to just import 31 rows of data. Select the checkbox and type 31 into the box that appears. Use the Select All checkbox to import all the years together and press OK. Look quickly at the data. From earlier, I noticed something interesting in 2006. Have a look at row 31. Is there anything odd? There was 13.7 millimeters on 31st September. That's very odd because September only has 30 days. We should always be on the lookout for oddities, but it is almost impossible to find them all by looking at the data. During the tidying process, we will explore some tools that will bring them to light in a more systematic and reliable way. The first step is to put all the data sheets together. For this, we go to Prepare, Data Reshape, Append dialog. Use the arrow on the Add button to select Add All and click OK. That worked! We now have 465 rows of data as we have joined all the years in one. The first column in the new data frame uses the names of each of the sheets. It contains the year, but it is in a character type column. We just want to include the second to the fifth letters in this column to extract the year. So, use Prepare, Column Text, Transform. Use the Substring tab. Add the ID variable to the Column to Transform box. Set the start value to 2 and the end value to 5. Call the column here and click OK. Pause for a minute to check the data frame. As a data detective, check that 15 variables are what you expect. There's the ID, year and date variables, plus 12 for the different months. So fine so far. The variable called date is not really that, it is the day of the month. Let's rename it to be more accurate. Right-click from within the date variable and choose Rename Column from the menu. The date variable will automatically be in the current name box as you right-clicked from within that variable. Type day into the new name box and click OK. We also want the months to go down rather than across. That's another data reshape job. This time, go to Prepare, Data Reshape, Stack. Select the month variables and add them to the Columns to Stack box. Select the Carry Columns radio button and add the year and day variables. Set names to month and values to rain and click OK. That's looking better already. Now combine the year, month and day columns to make a date variable, and that's quite easy, and you'll see why it's useful in a minute. Use the Prepare, Column Date, Make Date dialog. Choose the Year Month Day tab. The year variable has been automatically added to the year box, the month variable to the month box, and the day variable to the day of the month box. Set the month format to full name using the drop-down menu. Then click OK. Looking down the date column a bit, we can see that some of the dates are missing. Those are the impossible dates like 31st February. This gives us a chance to show how to filter the data. So, right-click again and choose Filter Rows. Choose Define New Filter. In the Define New Filter sub-dialog, add the date variable to the filter by box. Select is NA from the drop-down list. Press Add Condition and return. Back in the Filter dialog, press OK to view the filtered data. R-Instat indicates that a filter has been applied by showing the row numbers in red. You can see from the row count at the bottom of the data frame that there are 101 missing dates. The 2006 problem that was mentioned before is in row 2973. There are other impossible dates with zero rainfall, but this is the only non-zero value. We did check back to the National Met Service, but they were unable to help, so it is best to exclude it. Click in the top corner to mark all the rows. Then, right-click on the row numbers on the left-hand side and choose Delete Rows. You will be asked if you're sure. Click Yes. The data frame now looks empty, though the bottom row count indicates that there are still 5,479 rows of data. Right-click in the data frame and choose Remove Current Filter. The data are now in a tidy shape, but in an odd order. So right-click again from within the Date column and choose the Sort option. As you right-clicked from within the Date variable, it will already be included in the columns to sort by. So, simply click OK. The data are now organized chronologically by date. We are nearly there with our tidy data. Now, right-click to make the year variable numeric and also make the month into a factor. We can now see that the year variable is numeric as it no longer has the C beside it. And the month is marked as a factor column with an F beside it. That's now tidy. Are you impressed? I am. That was a lot of steps, but I can see they were needed. We have completely reshaped the data, joined all the years together so they can be analyzed as a whole, added a date column, and identified and got rid of all the missing date values. However, I am concerned that I started in Excel with the annual and monthly totals as well as the daily data, and after all this, I've lost them. That feels like a step backwards. You're right, and you will get the monthly and annual summaries again soon. We also combine the remaining steps with brief reflections about the Prepare menu. Perhaps you found the right-click menu was useful. It was used for renaming, sorting, filtering, and for getting the correct types for the variables. If you're not a right-click enthusiast, you can use the Prepare Data Frame menu for many of these tasks instead. Next, the Check Data menu is often used. Go to Prepare, Check Data. It includes the one variable dialogs that are also in the Describe menu and were used in Tutorial 1. The one variable Summaries provides a useful check of the data. Click on it to open the one variable Summaries dialog. Use the arrow on the Add button to add all the variables to the Variables to Summarize box. Leave our maximum factor levels at 12 as our only factor is the months and there are 12 of them, so click OK. This has summarized all the variables in this dataset. There is a date variable, 3 numeric variables, and a factor variable. The results all look sensible. For example, there are 5 missing values in the rainfall variable, and that is common. There are no missing values in any of the other variables, and we would have to stop if there were. The days of the month go from 1 to 31, and there are 12 months, all as we expect. We add a new variable to enable us to study the number of rain days. We calculate whether rain is 1 millimeter or more, and the resulting variable is called rain day. We could use the column calculator, but an easier alternative is the Prepare Column Numeric Transform. Select the rain variable and add it to the column box. Select the Logical Radio button. Use the drop-down menu to select more than or equal to and enter the number 1. Call the new column Rain Day and click OK. You can see that all rain days with 1 millimeter or more are given as true and dry days are false. As we are moving down the Prepare menu, we have got as far as the Column Numeric menu. Then there is the Column Factor menu that includes all sorts of manipulations we often need for categorical data columns. We have already used the Column Text menu to process character type data, and we use the Column Date menu. We have already used the Data Reshape menu to append the years and then to stack the months on top of each other. Now that we have our rain day variable, we are ready to make the monthly and annual summaries you wanted. They will be based on only the rain days with more than 1 millimeter of rain as you requested. Now, we use the Column Summaries dialog. Start with the annual summaries. Select and add the rain and rain day variables to the Variables to Summarize box. Select and add the year variable to the Summarize by box. Then, click on the Summarize button to open the Summaries sub-dialog where you can specify what you want to include in your summary. We untick the N totals box as we do not want the totals but leave N non-missing and sum. Use the Return button to go back to the main dialog and click OK. Here are the results. The sum rain gives the total amount of rain in the year, and the sum rain day column provides the total number of rain days with 1 millimeter or more in the years. Oh, that's a bit quick. I can also see the annual total in 1999 is the same as in Excel earlier, but these totals are now nicely in a single column. And notice that the 86 rain days in 1999 is not the same as Excel, which shows NBJ is equals to 97. NBJ is French shorthand because you only wanted those days with 1 millimeter or more. It's a shame there are those missing years, and just because only 1 or 2 days are missing in each of them. True, but one reason for using a statistics package is they provide different options for coping with missing values. Return to the column Summaries dialog using the last dialog icon. This time, tick the Omit Missing Values checkbox. For more detailed options for dealing with missing values, you can click on the Options button to open a Missing Values sub-dialog. Here, you can set maximum and minimum amounts of missing values allowed. However, we know from earlier that there are only a few missing values, so we are comfortable simply omitting them. Click OK. Why has the data frame gone red in the dialog? Did I do something wrong? Good spot. You are looking at the annual summaries, but you still wanted to analyze the daily data. So, from a different sheet from the one you are on. That is sometimes a mistake, because you usually want to analyze the sheet you're looking at. This time, it's not a mistake, so click OK. Oh, that's better. I also noticed the Excel sheet from 1999 gave the largest daily rainfall as 122 millimeters. Could I add that? Of course. Go back to the column Summaries dialog. Delete the rain day variable from the Variables to Summarize box, as this is a logical variable, true and false. It will not be useful to get a maximum. Click on the Summaries button again to open the sub-dialog. Select Maximum as another summary, click Return and OK. In 1999, the largest rainfall on a single day was 123 millimeters, and that was also the largest in any of these years. Now for the monthly summaries. Return to the dialog. Add the month variable to the Summarize by box. Use the arrow on the OK button to use OK and Keep. Back in the dialog, add the rain day variable to the Variables to Summarize. Reopen the Summaries sub-dialog and uncheck the maximum and end none missing, as we just want to add the sum of the rain days. Then press Return and OK. Now you see that this Reshape dialog has produced two new data frames, one for the annual and the second with the monthly summaries. This is just as you requested. Great! Thank you very much. Goodbye. Wait! Come back. We haven't finished yet. You need to save the tidy data. We really should have been saving the data as we went along. You don't want to go through these steps each time. Use File, Save As, Save Data As. If you'd like to choose where to save your data, click on the Browse button. Choose where to save the file and give it a name. Click Save, then OK. This saves it as an RDS file. Once it has been saved the first time, you just need to click on that diskette icon on the toolbar to save an updated copy. You should have started saving your data as soon as you had stacked it. But what exactly is saved? It is all the data from all the sheets, but not the results and other things in the output window. But I started in Excel. I don't suppose we could save into Excel? Yes, you can. You can also save it as an Excel file if you want. Use the File, Export, Export Data. Select the data frames that you'd like to export and add them to the Selected Data Frames box. Tick the Single File checkbox to save them into 3 sheets in a single Excel file. The Excel option is automatically selected in the Select File Type box. Finally, use the Browse button beside the Save As box to set your file location and click OK. You could also usefully do a bit more housekeeping and improve your data detective skills. Start with some more simple tidying. We renamed a variable before, this time we rename a data frame. Right-click at the bottom in the Append stack data frame and choose Rename. We assign it the new name Garua. Use OK and keep. Rename the next to Garua by year. And the next to Garua by month. And press OK. The bottom right-click options are also available in the Prepare Databook menu if you prefer. Selecting Rename Data Frame here will take you to the same dialog. Click on the Save icon to update your data and re-export the data using the same steps as before if you want to save to your Excel file. Now to improve your data detective and reporting skills. Earlier, we saw the rainfall had 5 missing values. In hindsight, we should have investigated them at the time, but it is never too late. We pull up our initial annual summaries again, those that did not omit the missing values. As a data detective, we now notice this happens regularly every 4 years. So, it must be the leap years that are missing. Examining the data for these years shows 29th February is always given as missing. This is the dry season in Garua, so the value would have been 0. So our action of ignoring the missing values was fine. However, we use it here to show an important feature of the data preparation stage. You always find points to report, and R-Instat has a comment system for this purpose. Returning to the Garua by year data frame, we add a comment to the first leap year, 2000. Right-click in the Sum Rain Day column in the year 2000 and choose Add Comment. Type a comment on what you found. We type missing value on February 29th in each leap year. When you press OK, R-Instat makes a new data frame with a single row containing your comment. We then remembered the oddity from 2006 on 31st September and added a second comment. By doing this, you are preparing a report on the data. If you are a spreadsheet user, we hope you will be comfortable adding R, perhaps through R-Instat, to your spreadsheet use. We are not suggesting you abandon them, and you have seen how easy it is to read from a spreadsheet and also to write back there. But repetitive copy-pasting is a risky and time-consuming operation. Whenever you're considering this, then ask if there is a better way. And note that the tidying only has to be done once, then you don't have to repeat it each time you do more analysis. From now on, you start with the tidy version. We hope this tour has enthused you to study whatever data you have for analysis. If not, then either take comfort from the fact that the tidying process and initial checking part may be trickier than the subsequent analysis. Also, it only has to be done once. So, you are already on the home run since you have your tidy data.